इसका लिंक मुझे Okay, so in the previous first 2-3 questions, so in the previous 3 questions which simply give the glimpses of thermodynamics and statistical mechanics, that was simply the first law of thermodynamics and the enthalpy, which you have seen del U is equals to Q minus W, and the second one is enthalpy H is equals to U plus PV, and the system. So as we have studied very earlier that U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system. In the similar way, the thermodynamical potential and enthalpy can be obtained in form of second equation, H is equals to U plus PV. The P is pressure and V is volume, and if you find that equation with the help of Q, so Q is equals to del U plus P dV. Okay. So del V is a very you can say small change. So this is a small change of energy which you are observing. Okay. So here now the system work according to the work done. So the thermodynamical system is usually a gas that is doing the work. The work done by the gas at constant pressure is P is equals to WV. Here P is equals to del V, W is equals to PD del V. So that this del V is a small change where P is a pressure term, this is P is a pressure term. So this thermodynamical law find application on the systems which works here. In the similar way, when we talk about the internal energy of the thermodynamical identity, so that equations can be derived in some different way. So these are also some other aspects which we will cover here. My fourth and fifth equation is Helmholtz free energy, which give you the equation F is equals to U minus Ts. Ts is the final entropy of the system. Actually, entropy is a word which increase from very ground state to the higher order. Entropy always increase in any form. So this is a type of a entropy diagram. Okay. So there is a diagram which you see in point number 4 here. This covers that this is a diagram in which Ts is in the negative order of the x-axis, going from left side toward the right, and you can derive the equation in a very easy way. And if you go to the y-axis, which is going from upside to down, the PV terms is added to it. My fifth equation is Gibbs free energy. So it's a energy in which U plus PV is there, and minus Ts final entropy is also involved. So Gibbs free energy is a composition of first law of thermodynamics with the negative value of Ts or the entropy, final entropy. Okay. So these are some of the very few fundamental equations, which give you a clear idea about the thermodynamics. Now I am rubbing the equation. I hope you will have seen it. Now rubbing this entire again. there are certain things which comes into the picture for the thermodynamical identities. So, thermodynamical identities has to be also studied during any rigorous studies in thermodynamics. So, here we will go on some of the terminologies which are used here in the thermodynamics and identity. So, as you know, du is equals to Tds minus Pdv. So, U is the internal energy, U is the internal energy. Where S is entropy, V is the volume, T is the temperature, P is the pressure. So from this equation, where D denotes the, actually sometimes student ask what is D. So this is a differential, total differential, it is a total differential term. Some mathematics students can understand it. It is a total differential. Total differential means the terms are totally differentiate and the value will be obtained in a complete way. Partial differentiation holds, partial differentiation is like this, dou upon dou x. So these are partial and these are total. So you don't have to confuse with this. So coming on the very generalized some very important equations which come in GATE exam to solve and other NET exams, even in master's level, some exams are here. So these equations which come from this fundamental equation is du is equals to Tds is equals to q, or ds is equals to q by t. So Tds is equals to q. This is one aspect. This is one aspect. Now the second aspect is, here the volume is constant. Always remember, for constant volume. For constant volume. And here the entropy is macroscopic. It's very big, macroscopic entropy. Okay. Now the second equation which comes from the primary thermodynamic identity T d is equals to T ds minus P dV is, the second one is 1 by T is equals to dou S by dou U V comma X. Sometimes I am using new terminology here. So I am using N. Here the N is there. So this is also for constant volume. Under constant volume, you will get this equation. Constant volume. Okay. So it is a definition of a temperature. This can be defined for temperature. Temperature definition. As you see, we have find it for temperature. So it can be defined for temperature. for constant volume. Okay. So, this is a partial differential equation. If you see, these partial differential equations give you the order of some value of temperature, not the complete. If there is a complete differential equation, it will give you the complete description of the temperature profile or the temperature gradient. Okay. Now, the third is from the main equation, that is the thermodynamical equation. I am just rubbing this. So, I am rubbing this portion. So, the third equations which shows the constant of u. So, the third equation is, third one is for constant u, mean constant u mean internal energy. For constant u internal energy, the equation show obtain will be P is equals to T dou S by dou V u comma n. Okay. So, this equation is very consistent with the ideal gas law, consistency with ideal gas law. With so, here the constant is u, mean internal energy is constant, and the equations to obtain is this. It is a very classical equation. This equation is very classical. So, it is a partial differential equation obtained in the form of P, and it is very consistent with the ideal gas law. So, I hope there is no problem in understanding this third equation obtained from the primary equation, that is K. K. Okay. Now, the second last equation is here. Fourth is du is equal to minus P dV. Okay. So, it means that the internal energy is of the order of negative P dV, negative P dV. Okay. So, this is an adiabatic process. Always remember, this is adiabatic process. Sometimes students are confused, what are adiabatic process? So, these are adiabatic process. If you see these type of equation in which minus P dV stands, so these are adiabatic equations. Anywhere you obtain this type of equation, these are adiabatic process. Now, the last equation, I hope that the all four equations are clear to you, and you can use either partial differential equation or the complete differential equation. It can be obtained very easily. Now, the more fundamental equation is somehow we can obtain from thermodynamical equation the fifth equation, which is du is equals to dq minus dw. So, this is the first law of thermodynamics, first law of thermodynamics. Okay. So, these are the standard equations which give you a clear idea and how to treat them on the basis of constant u, v and other factors. Okay. So, I do not think that there is some ambiguity in this entire equation which we derive here in thermodynamics. And one more thing, the temperature from the thermodynamics identity can be obtained also. So, I am deriving a thermodynamical equation also. I hope everyone has written this equations 1 to 5. So, I am rubbing this one. So, here now the temperature scale, temperature from thermodynamics identity we will discuss later on. So, this is the end of the session. We will explain temperature from thermodynamics identity. Here we will find a very fundamental equation which is very important. We have to find u is equals to 3 by 2 of kT and kT. So, we will find later on the next day. Hope you find the physical significance of 1 to 5 thermodynamical identities, and we will discuss this thing in the next class. Thank you.